Hi students, in previous class we discussed a factory design pattern, what is the main intent, what it is also known as, and what is the main motivation, and what are the uses of a particular design pattern factory method, what is the applicability and structure, and what are the participants. And now in this video we discuss what is the collaboration and consequences, implementation, sample code, noun uses, and related patterns. Now we discuss the main collaboration in the sense how classes and objects collaborate, how to carry their particular responsibilities. Okay, in this concept to define the factory method, whatever we need to create some objects without exposing the creation logic to the client, we need to create, the creator relies on its subclasses so that it returns an instance of the appropriate concrete product. Okay, the creator relies on its subclasses, whatever we need to define the factory method so that here it returns an instantiate of the suitable concrete product. Coming to the consequences, what does the consequences says to you? Consequences describes its results of whatever you need to applying this pattern, of whatever we need to understanding of this particular pattern. So here what we need to discuss here, whatever the factory method we need to remove, so we need to bind the particular application specific classes into your code. So here the code only deals with, whatever the code here deals with the product interfaces, therefore it can be work with any user defined a concrete product classes. Here what does it says? We need to eliminate the factory method, so we want to link the application specific classes into your code implementation. So the code only mainly deals with whatever the product interfaces we need to take, therefore it can only work with any user defined a concrete product classes. Here in this subject point of consequences view, there are two additional consequences of the factory design pattern needs, ma'am. First one is nothing but provide looks for provides hooks for subclasses. In the sense, it's a meaning whatever we need to creating a particular objects inside a class with a factory method, it should be a flexible one. Then only we need to creating an objects without instantiating the classes directly. So the factory method gives subclasses a hook for supplying an extended version of that a particular object. Okay, here the factory method whatever they gives to you, in the sense we need to take some subclasses, a hook for providing, in the sense supplying an extended version of an object. So here the main motto of this document example here, whatever the document class, we could define a factory method called create file dialog that creates a default file dialog object, okay, for whatever we need to opening an existing document. Okay, coming to the second additional consequences of factory method pattern is, we need to suppose it to connect a parallel class hierarchies. Okay, what we need to connect there? A parallel class hierarchies. What is the main motto of this connects parallel class hierarchies in this concept of factory method? It is only called by creators, it is only called by creators. Okay, the parallel class hierarchy is whatever the result here, it describes the result whenever the class delegates some of its responsibilities to its a separate class. Let us, if we have to consider a graphical figure ma, whatever that can be handled interactively, that is, they can be a stretched one, they can be stretched and moved or rotated by using the mouse. By using the mouse operation, we need to perform some operations. We need to implementing such interactions is not always easy ma. We need to oftenly required, we need to storing and updating the particular information that records the state of the whatever we need to manipulating at a given time. Okay, these constraints here, these constraints in the sense, these conditions, it is very better to use a separate manipulator object. We need to implement the interaction and we need to keep track of any manipulation specific state that's needed to you. Okay, in this example, in this figure, we need to understand the whatever the parallel class hierarchies. Here, look at this diagram. Look at this diagram here. What the figure shows you here, the figure, the class is a figure. Okay, whatever here it provides, what it provides, a create a manipulator factory method a function ma. What let's take some clients. What the client creates there, a figure corresponding the manipulator. So the figure subclasses override here. Look at this, the figure here, figure we need to create some manipulator function ma, that subclasses override this method, that subclasses override this method, whatever here written, to return an instance of the manipulator subclass. We need to instantiate the manipulator subclasses, that's right for them. Alternatively, we need to move the figure class, it may implement create manipulator, whatever they return here, to return a default manipulator function, it returns it manipulator class, it returns a figure subclasses, whatever we need to simply inherits, whatever we need to simply inherit the default function, the figure classes that need to corresponding whatever we need to manipulate in the subclasses. Hence the hierarchy in the sense level by level, or only it will be partially the connected parallel class hierarchies here. So you can notice there how the factory design pattern method defines the connection between here the two classes, here the connection between the two class hierarchies. So here it localize to encapsulate the knowledge, however the knowledge we encapsulate there, which classes it belongs to that. Okay, the figure, the class create manipulator, and that manipulator creates some down click function, drag function, up click function. We need to inherit it there, we need to extend the line manipulator class and a text manipulator class. Okay, finally the figure what that explained, it provides a create manipulator factory method that lets the client creates a factory how to corresponding the manipulator. Okay, and coming to the implementation of this section ma, implementation, in this concept of implementation, in which design pattern, in which situation, how we can implement whatever we are when we are applying the factory method. Okay, here look at this implementation we need to study here. First one, we need to consider the following issues ma here. When we are applying the factory method design pattern, the first one is two major varieties. In the sense, the two major varieties here we need to study the two main variations of the design pattern factory method. First one is the case when the creator class is an abstract class, listen carefully, the whatever the creator class we need to create, it is an abstract class and does not provide an implementation for the factory method, it declares. Yes, exactly, an abstract class is a class that contains at least one abstract method. That abstract method contains for all the implementation of these methods, but here what this says, it doesn't provide an implementation in the code, it doesn't provide an implementation in the code for the factory method, whatever it declares. That is the first main variation of the factory design pattern method. And coming to the second, the case whenever the creator creates a concrete class. A concrete class is a class, it contains for the all the implementation of this method, and we need to provide a default implementation. We need to provide a default implementation for the factory method. It also provides to possible to say how to have to create an abstract class that defines a default implementation, but this is less commonly to say that here. Okay, the first case here requires a subclasses, whatever the subclasses we need to define an implementation, because there are no reasonable here defaultly. Okay, and coming to the whatever the concrete creator uses the factory method primarily for it should be a flexible one. Okay, and coming to the second implementation here, parameterized factory methods. What we can say, a parameterized factory methods. The another variation on this pattern, we need to study the factory method. We need to create a multiple kinds of product. We need to create a multiple kinds of products. So the factory method takes a parameter, whatever that identify the kind of object we want to create an object there. All the objects of this particular factory method, we need to create an object. It will share the product interface. Okay, for example, we need to take some application. Application might support different kinds of documents. You pass a create document an extra parameter. Okay, an extra parameter is we need to create a document. Whatever we need to specify the kind of a document we need to create. Okay, this is the second variation of that particular implementation. And coming to the third one is nothing but the implementation. We need to study their language specific variants and issues. The main concept of language specific variants and issues, in the sense, if we have some different languages, the different languages, it's lead to themselves other interesting variations and caveats. In the sense, we need to take some small talk program. It's a language, it is oftenly uses a method, whatever the method that returns a class of the particular object, it should be instantiated. Okay, it like we have to take some a creator a factory method, it can use whatever use this values, we need to create a product, and concrete creator may store, or even we need to calculate this value, whatever the result here, the linking for the type of concrete product is to be instantiated. It is the third key point of implementation. We need to specify specific language variants and whatever the issues. Here the different languages leads themselves other interesting variants and caveats. Okay, and coming to the sample code of factory design pattern method, the sample code we need to study about there. For example, we need to take some function, whatever the function here, we need to take some create a maze. The maze builds a maze is the game is there, create a maze, we need to build and returns a maze. One problem with this function, that it's very hard code. Whatever we need to create an object, the classes of mazes, rooms, doors and walls. We will introduce a factory method. Let us take some subclasses we need to choose these particular components. First of all, we will define a factory a method in maze game for whatever we are creating their maze room, wall and door objects. Here look at the sample code here. The class name will be a maze game. A public, we have to declare the public. The maze asterisk, we need to create some maze function. And the comment here, a factory methods here. Factory methods here, if you have to suppose to take some virtual maze asterisk, we need to make maze function constant and we need to return some new maze. Likewise, if you have to take some room and wall, we need to return some new room and we need to return some new wall. And virtually, the virtual constructor, like some we have to take some door also, maze, room, wall and a door. We have to be written new doors, new walls, new rooms, new mazes. Here what that the code will explains to you in the sense, each factory method here returns a maze component. Component in the sense, it's a one of the tool amma. Here it returns a maze component for whatever we want to given as some type. The maze game, what here provides some default implementation, whatever that returns some simplest kinds of mazes, rooms, walls and doors. Okay, now we can rewrite create a maze to use these factory methods. Look at here this sample code of this here, maze asterisk, maze game and scope resolution operator. We need to create some maze. Okay, rooms, we need to make a room and r1. Let us take some variables r1, r2. We need to take some door, the door, create some doors r1 comma r2, and we need to add room to a maze and we have to add one more room to a maze. Let us declare r1. We need to set some side north comma make a wall, and coming to r1 attends to set side of east comma the door. East side we have to take some the door, and south side we need to make a wall, and west side we need to set aside, we need to make a wall. Okay, likewise we want to create like this, and finally we need to return a maze. Okay, like different games we need to take some subclasses of this maze game. We need to specialize some parts of the maze. Okay, in this subclass we can redefine all the factory methods, whatever we need to specify some variations. Okay, in products. Okay, this is the sample code of a factory design pattern method. And coming to the known uses of this concept, known uses, whatever the known uses we are taking here, factory method, it pervades a toolkits and frameworks. We need to support the preceding document example here also, and we can take some Smalltalk 80 model view controller framework. It also we can use there. And coming to the one more use here, a class that includes embedded SQL structured query language statements. It overrides this method as a class method, and we need to return here structured query language parser classes. Here we need to now use here Orbix ORB system from IONA Technologies. Uses a factory method, whatever we need to generate an appropriate type of proxy. Whenever an object requests a reference to a remote object, so we need to, the factory method makes it very easy. We need to replace the default proxy, okay, with one, the whatever that uses the client side caching. Okay, these are the known uses of factory method and Smalltalk 80 model view controller and Orbix ORB system from IONA Technologies. And finally, it is very easy to replace the default proxy, whatever the client side caching. Okay, here we need to use some known uses. Okay, and coming to the whatever the related patterns of this factory design pattern, in the sense, the first one is abstract design pattern. The main intent, how to create families or products related to that particular objects without instantiating the classes directly. This method is very oftenly implemented with a factory method. The motivation is the best example of a factory abstract factory pattern. It illustrates, we see. And one more we take a prototype don't requires subclassing creator amma here. However, they are oftenly requires an initialization operation only on the product class. Okay, so the creator uses initializes the objects. Whatever the factory method does not require such an operation. So the factory methods are usually called within a template method amma. So in this concept we see a document example. Okay, new document is a template, a method. These are the related patterns of factory method design a pattern. Okay, if you have any doubts, can you please contact me. Thank you, ma.